Welcome, viewers, to the Daily Space Weather. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you from the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. We'll go again and bring you the most detailed imagery of the closest star, as well as the most comprehensive daily space weather you'll find in the known universe. We've got major disturbances happening in Earth's ionosphere at the moment. And make sure you stay tuned for our ionosphere coverage section, as we've got several different events happening, coronal hole high-speed streams as well as coronal mass ejection impacts. Here we're looking at some huge filaments, which are maybe 6 to 8 Earth diameters there in size there around the north heliographic polar region. Let's go around the horn here. We've got a reduction in sunspot and radio flux activity since yesterday, as the sun has been ramping down, at least on the Earth-facing portion of the solar disk. Here's your northwestern limb. Here's your southwestern limb. These wavelengths are both ionized iron, part of the extreme ultraviolet wavelengths. And here is your southeastern limb. Great view of a coronal hole there. These wavelengths also show the lower corona as well as the extended corona. And we do have another active region just rising over the northeastern limb. As we make the video, no umbrae were visible yet, so we're still waiting. Maybe by the end of the video we will have some updates on that, whether or not it's a sunspot or just a plage. Today's featured product is Do Not Pole Vault the Caldera, and I'm wearing it myself. Check it out. It is our best seller, and thanks to everybody who's picked up merch over the years, we decided to attempt to supplement our incentive to continue making these videos by offering merch. Some of it's serious, some of it's in jest. This one's sort of a little bit of both. We'd like to sprinkle some humor in, so please don't pole vault the caldera. No matter how bad things seem, don't worry, they could get worse. However, our finest days lie ahead. So if you're going on a volcanic vacation, leave your vault pole at home and don't pole vault the caldera. We need the views on YouTube. So thanks to everybody who's tuned in. This design features our YouTube URL as well as Smash-O-Mash.com, a site that we launched in response to the pathetic censorship of Meta. If you visit the Redbubble link below the video, you'll find the items in order of best selling. There are our designs. And getting back to the sun here, only one sunspot grew yesterday. That's yesterday plus today. I mean, check it out. You've got this one sunspot group right here. Besides that, things have been basically ramping down, and we can expect a further decrease in the sunspot number and radio flux today as this group sets. So a big decrease there in solar activity. This sunspot group here appearing right near the equator, just south of the equator. And it does indeed have a south pole leading umbra there. And let's take a brief look at what's going on ground level. We've got some volcanoes erupting like Shivaluch. Not sure about the size of the volcanic ash plume, but it is erupting. Most likely, volcanic ash not identifiable in satellite imagery. Sakurajima flight level 070, it's a 7,000-foot ash plume over Kyushu, Japan. Subanose-jima, 7,000-foot ash plume from Subanose-jima as well. Merapi, flight level 140, it's a 14,000-foot ash plume over central Java. And looking at North American volcanoes, starting with Popocatépetl. It's exploding, producing a 20,000-foot plume of volcanic ash over central Mexico. Flight level 200 from Popocatépetl. Sancha Guido in Guatemala, flight level 130 as it explodes. Flight level 150 over Fuego as it explodes. It's a 15,000-foot ash plume. No emissions from Nevado del Ruiz in Colombia. Intermittent puffs of volcanic ash from Sabancaya in Peru. And Villarrica has slowed down in terms of activity. Looks like its eruption is weakening over the past 2 weeks. Let's take a look at seismicity also. No major quakes over the past 24 hours. There are the past 90 days. And let's take a look at the USGS list here. So, very low number of quakes here over the past 24 hours, actually. Very low number of quakes. Surprisingly low number of earthquakes there. And only a couple over a 5 magnitude. This is an interesting one indeed. A 5.4 in the central Mediterranean. That one came in at 16:36 Universal Time yesterday afternoon. Chile also had a 5.5. I think that was the largest quake of the past 24. Mid-Atlantic Ridge had a 5.0 there, right around the equator on the Atlantic Ocean Mid-Atlantic Ridge level. And just remember, folks, any earthquake could be a foreshock. Anyway, let's get back to space, as it's an exciting day for space weather. Some major NOAA alerts might have come out. We didn't share those with the Smash team this morning because they didn't look like they were going to pan out. So we just kind of let those slide because it looked like they were going to be wrong. It looked like a sudden impulse, but it didn't really happen. So here's some more 24-hour videos for you. There's SDO 171 by itself. The previous was including ionized helium 304 angstroms. And we'll also add 131 angstroms. So again, another dip in the radio flux in the past 24 hours. We've seen the 10.7 drop all the way down to 139 solar flux units. And if you're new to the channel, the upper chromosphere and lower corona, an area where there's lots of intense and interesting action going on, to say the least. That emits radio frequency at 10.7 centimeters. And there is the 1-year graph of the radio flux. It is a proportional data set to sunspot number. When we see high levels of sunspots, we see high levels of radio flux. It tells us a little bit about the physics, at least of the upper chromosphere and lower corona. Now, we did see a massive increase in the magnetic field. We'll get to this in a moment. But first, the Space Weather Enthusiast dashboard. So forecasting another CME impact tomorrow. So we did indeed see the one today coming just about right on time here. Maybe a couple hours late, but pretty good forecast there by NOAA for the CME. Again, another one expected tomorrow. We are expecting this to be a little bit more minor than the one that struck today. But it is always good to over-forecast instead of under-forecast. And so let's take a look at Earth's magnetic moment from space for the past 4 hours. This is our Geospace Magnetosphere movie. It's showing you magnetohydrodynamic pressure. And it is a high-pressure environment at the moment, as a coronal hole high-speed stream has been supplemented by a coronal mass ejection. And again, we are expecting another one tomorrow around the same time. So here are ground magnetic perturbations, and things have actually calmed down in the past couple of hours here. So it looks like that thing has subsided. There still is a coronal hole high-speed stream expected to be coming through. So that's our ground magnetic perturbations for the past 4 hours. And we've decided to start showing this North American view here when we do see moments of geomagnetic storm and geomagnetic unrest. So since we're close to the threshold here, we're going to show it. I'm actually letting it play through twice here. And we'll also show the ground magnetic perturbations on a global scale. Bring that back. That'll show you the most likely places to see telluric currents, railway, pipeline, and power grid induction, the aurorae. And this depicts nanotesla, which is magnetic flux density at the ground level. If there was a scary, spooky geomagnetic excursion going on, you'd see extreme changes to this, and since it refreshed, let's let it play through. If we were seeing a geomagnetic excursion that was accelerating, we would see extreme changes in here, and we wouldn't see these ground magnetic perturbations focused around the poles. We'd see them migrating somewhere. And this is just another indication that Earth's magnetic fields are not fixing to flip. You'd be more likely to see the polar excursion snap back toward the geographic poles than you would be to see the geomagnetic excursion flip the poles. That's a lot less statistically likely scenario. So it's nothing to be scared of in the slightest, in my opinion. If you've got another opinion, feel free to leave it in the comments. We encourage all free speech. We encourage all legal speech, and we won't mute, ban, or block you. However, you might be berated in the comments section, because remember, folks, ignorance is the root of all knowledge, and there are no stupid questions, but there are certainly stupid people. Hopefully you're not watching their videos on YouTube. So here's our planetary K index. And NOAA was forecasting a KP6 or 7, but the likelihood of that has now waned. So if you've got email alerts about that from NOAA directly, we curate the email alerts that we send to the Smash team at smashomash.com/Smash team. And I saw the fields dropping and the BZ turning positive, which we'll explain here in a moment. Planetary K index current conditions are 3.67. It's geomagnetically calm, just this side of geomagnetic unrest conditions. So let's take a look at Lagrangian point 1. Again, the ionosphere is extremely perturbed, which we will show you in the bonus features segment. But at Lagrange 1, we'll have the measurements from the, in this case, the ACE and Discover. So this is interesting. When the CME impact happened, we actually saw a very strong field there. So the field was as high as 25 nanotesla. It came up from only 8 nanotesla. So it over 3 times stronger field there did appear, but we didn't have a strong negative BZ signal. So that's the vertical component of the magnetic field, which is the red line depicted in that top frame. And yeah, so we never really saw those KP7 moments, and we're not expecting it. It looks like this thing is subsiding now. You can see this big increase in the solar wind density and speed at the same time. That's a coronal mass ejection impact. Also a signal showing up there on the bottom pane. That is the plasma temperature. So anyway, current conditions are still elevated here, as there is a background coronal hole high-speed stream likely continuing on. Just under 500 kilometers per second for the solar wind speed, solar wind density about 18 protons per cubic centimeter. And again, we are seeing not only the field weakening here, but we are also seeing it strongly shift back into positive territory for the BZ. So current conditions for the BT-BZ are 11 nanotesla for the BT and BZ positive 8. Next are GOES magnetometers here, and you're seeing some sawtooth readings showing up there around midnight local time for the satellites, which is what these M's denote. The N's denote noon local time for the satellite. And let's take a look at the heliospheric current sheet next, as we do on the videos daily. So that's what's going on in terms of the heliospheric current sheet and its polarity. Earth is still solidly in a North Pole-oriented current sheet, depicted there in green. No sudden changes expected there. Keep in mind the magnetic environment can change with basically no warning. Here's our line of sight field plot. Again, Earth is kind of right toward the middle of a North Pole-oriented current sheet as we watch the solar cycle 25 field reversal process progress. Here's our coronal hole view, which depicts that. So we are still seeing some North Pole magnetism right around the geographic North Pole. That needs to leave before you could call this solar maximum, and we're just not there yet. Let's take a look at 211 angstroms from SDO and indeed North Pole-oriented coronal holes. Let's actually bring up the latest image here just to make sure we're not missing anything. So we do have some South Pole coronal holes here rotating in the southeast. So down here you'll see these get more well-defined. Also, there is a sector boundary crossing somewhere in between there. So somewhere like here, there must be a sector boundary crossing there. This is a North Pole coronal hole, and the current coronal hole high-speed stream is from this setting coronal hole over here in the west. And let's move to sunspots, as the Earth system is where the excitement is really happening today. Not so much on the sun directly. That's another 24-hour video, by the way. So here is our flare probability monitor and solar flare scoreboard. And yeah, you'll see a reduction in sunspot number today. Although this group up here might be promising, it does look like it is probably a sunspot based on how much material is suspended by magnetic fields up there in the northeast. So we'll show you high-res imagery of that limb. At the moment, again, things have been declining for the past about week. Let's take a look at sunspots here from SDO. There is your 24-hour SDO 94 angstroms plus SDO continuum. And here's a closer view of that. We kept the 94 angstroms on there to show you the active regions. The most flaring came from these areas down here. And let's subtract 94 angstroms to just show you the sunspot activity for the past 24 hours. Pretty sweet. And let's move to energetic particles and solar flaring. So we did see a decrease here in the GOES proton flux. That solar energetic particle event now subsiding officially, and you should see the polar radio blackouts going away also. So that's your GOES proton flux here. We did see some couple day events there. They weren't of super high magnitude or anything. And let's look at solar flaring, which has been very minor here. The sun has retracted back into a B-class background output. So the current background output is about a B6. We've only had some minor C-class intensifications over the past 24 hours. Here are two wavelengths great at showing flares. They are still part of the extreme ultraviolet spectrum. They're not actually showing X-rays, they're just good at showing the ultraviolet emissions of iron nuclei. So that's ionized iron, 134 plus 94 angstroms the past 24 hours. And let's talk about this new sunspot. There's a great view of that. And I don't know what I'm going to talk about. I don't have anything to say other than it's grown slightly since yesterday. All right, so let's take a brief moment to orient ourselves here. Quick update on Cygnus X-3, which is a star that you can see. It's actually the brightest intrinsic object visible from Earth. The star Deneb, the tail of the swan in the constellation Cygnus, otherwise known as Alpha Cygni, has actually descended into an X-ray quiet state. So we saw a very extended X-ray excited state from Cygnus X-3, possibly the most important star in the whole Milky Way galaxy. Anyway, that's what's going on overhead right now over Lehigh Valley, Pennsylvania. You've got the Moon, Saturn, Mercury, Jupiter, and Venus just rising. And let's briefly talk about Cygnus X-3. So this is a massive X-ray binary, Cygnus X-3. It's the only known cosmic ray point source, and it has descended into an X-ray quiescent state. So you can see right here it spent an extended period of time at a high X-ray state. Now it's dropped back down to a very low X-ray state. You can see here for an extended period it was way up here. And now it's between 0.1 and 0. So now it's way down here. So it's gone into a much lower X-ray state there. And we're trying to get somebody like the James Webb Space Telescope to take a look at this object, especially during a transition from a quiescent to a loud X-ray state. Anyway, if you want to read more about Cygnus X-3, you can find information on our forum at smashomash.com/forum. It's contested, the actual distance. Some people believe it's as far as 37,000 light years away. I've heard estimates as low as 4,000 light years. And in some ways, you're inside of Cygnus X-3's poloidal field, because it does have a jet that is oriented directly at you. That's what allows it to be a cosmic ray point source, we believe. And it's interesting indeed. Check out the Cosmology Forum again at smashomash.com/forum. You can read all about Cygnus X-3, and good morning to Mike Bordages. Next, we're looking at a solar system forecast here. This is what's going on as far as heavenly bodies, local ones. Let's advance this 1 week. 1 week until the new moon, folks. The new moon will fall on the 22nd of March. It's my favorite moon phase. It's associated with sleeping well and no werewolves. So that's always a plus. Keep in mind that imagery is not to scale. And let's take a look at some coronagraphs. So it's been very quiet as far as coronal mass ejections in the past 24 hours as well. Quiet stuff. And we've got no more images for today. We do see some cosmic ray strikes there on the Soho-Lasco C2. You'll see a bunch of like ovals appear there, right there. Those are likely relativistic particles from the sun. And let's move on to look at the view from Stereo A and Soho-Lasco C3. So there are 90 frames. Let me just make sure that I've shown the right things here. All right, we are good. So there are 90 frames. You can see Mercury there, both on Stereo A and the Soho-Lasco C3. Looks like no additional Earth-directed coronal mass ejections. We'll show you some 24-hour videos as well. Just pay attention to the date stamps when we show this, because those are not synchronized. And, you know, they're different spacecraft. They're quite far away from each other. So here are our 24-hour composite videos. That's depicting SGO 304 angstroms. And then the Soho-Lasco C2 in red, Soho-Lasco C3 in blue. Looks like some missing data there or something. Yep, you can see the SDO continuing to play. So some data gaps there, but no indication that there are any Earth-directed coronal mass ejections. How about if we zoom in one more layer? Maybe some CMEs that were missed there, but they certainly don't look like they're very extensive. Continuing on to look at filaments. And there are still quite a lot of filaments on the Earth-facing portion of the solar disk. Thanks to everybody who's joined us over on Twitter. Yeah, Twitter. We talk about things that are not space weather and all kinds of stuff that we don't cover on the YouTube videos. So we've got exclusive content on most of our social media sites, so make sure you join us over there at Twitter, all over the internet at Smashomash. And yeah, if you want to name filaments after living people, join us over there and follow the hashtag #NameThatFilament. That's what's going on at the ground-based solar observatory at Cerro Tololo, Chile. Lots of filaments on the Earth-facing portion of the solar disk continue. And once again, I would remind our viewers that you don't need solar flares, you don't need sunspots, and you don't need filaments, frankly, to see coronal mass ejections. You can see coronal mass ejections without any of that stuff. And sometimes we even see CMEs coming from the far side of the sun there and ending up earthly directed. So thanks for leaving a comment. General disturbance. And yes, that filament does look like a dancing stick man. Good catch. It's a pretty good one. And once again, don't forget to join us on Twitter. Anybody able to identify this image that we put as our new cover yet? If you can't, you probably, well, I won't give you any more hints. Anyway, here's the past 24 in just 304 angstroms, the ionized helium wavelength from SDO with its great high-resolution imagery. As we are about to move to our bonus features segment, and let me tell you, it's an interesting time for the ionosphere. We've been seeing some major anomalies. Here's the past 2.5 hours from Vigo's 16 SUVI. Let's take a brief look at that crown prominence up there. It's starting to look like a Christmas tree, folks. Is the sun about to light you up like Christmas? Please tell us that you're not frightened of the sun. It is the provider of all light and life on the planet. You shouldn't be spooked of it. You should not be spooked. All right, let's zoom out. The sun is not going to kill you, however terrible decisions by humans might. So we did actually have a CME here just recently propagating from over here somewhere. We'll have to wait for some data on that, and maybe we'll make another video later today about it. However, I suspect it'll be somewhere off to the east and not earthly directed. That's my story, and I'm sticking to it, and that brings us to our bonus features segment. So we've got some significant charging hazards here. They have subsided a little bit, but there's the satellite's community dashboard there showing some significant surface charging hazards over much of the Pacific Ocean. Those low-energy electrons build up on the outsides of spacecraft, and they can cause some minor communications breakdowns. And wait till you see the ionosphere. It is pretty jacked up. Anyway, here is the GOES electron flux. And you can see that is cratered, as we sort of expected, and NOAA expected it as well. So this steady decline, we can expect this to stay low here until we see the CMEs and coronal hole high-speed streams subside. Then we can expect another uptick in the electron flux. For now, that looks pretty legit to me. That's NOAA's forecast. Here's the one-year graph for the electron flux. And let's take a look at the F layer of the ionosphere, which is extremely anomalous at the moment. Keep in mind, March is the most geomagnetically effective month. So the F layer is at 300 kilometers of altitude. It's one slice of the atmosphere in vibrational frequency. And if you're used to looking at this imagery, you will definitely see some major high-frequency anomalies. So I don't remember ever seeing that much of the map lit up at 14 megahertz. Huge portion of the map lit up there at 14 megahertz. So that's also rapid shifts there. So huge variations happening in the ionosphere there. And if you're not used to looking at that imagery, that's okay. We'll show you the anomalygram as well. So here's the anomalygram. The previous was the raw vibrational frequency. This is anomaly in megahertz from the 30-day median. And you can see rapid swings there from low to high frequency anomaly. Wow. Major ionospheric havoc being wreaked by the incoming coronal hole high-speed stream and coronal mass ejection. So we can expect these anomalies to continue here. And wow, that is a jacked up ionosphere. So huge variations happening, mainly of the high-frequency anomaly variety. Let's bring up the latest image. There it is, 1230 universal time ionogram and 1230 universal time anomalygram, showing both high and low frequency anomalies. Low frequency anomalies here over Western Europe, actually, and high frequency anomalies here over the Americas, also the South Pole. Anyway, continuing on to show the total electron content, we'll show the global scale total electron content forecast. It's the free electrons out to about 12,500 miles of altitude, the location of the inner portion of the outer Van Allen belt. So you've got material in the outer Van Allen belt, also the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere all depicted here. Those free electrons can cause GPS errors. They're actually fairly coherent here, so I would expect this to actually become a little bit more anomalous throughout the day today. Kind of surprised that this is as orderly as it is. So, but that's the total electron content, the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. Surprisingly orderly today, despite all those ionospheric anomalies. So next we'll show the latest SDO intensitygram and latest SDO magnetogram. Of course, we do have this active region rising up here. Doesn't look like a sunspot yet. I don't see any umbrae. Do you? Let us know in the comments what you think. There are clearly no umbrae visible there. Anyway, here's the full disk rock back. We do have some magnetically organized spots happening down here. So a couple new sunspot groups there. At least this one is a new sunspot, so we may have another named group there. And the most significant flare player is this group over here. So that is the most magnetically complex group. It is Beta Gamma Delta class. This one up here is reverse polarity. How do you like that? It's got a leading North Pole umbra and a trailing South Pole. So one backward polarity sunspot there. But this is the major flare player. Also, this group here might produce some flares as it sets. It is not magnetically complex, though. And let's move on here to our meteorology segment. An interesting report about snow, just to reiterate. We've talked about it a few times. And before we get to our meteorology segment, take a moment to press like and subscribe if you enjoy the content. Congratulations on realizing the channel exists on YouTube. And press the share button, comment, etc. Please don't forget to visit our links, help support the channel, as YouTube has been doing a truly pathetic job of promoting the most comprehensive daily space weather videos in the world. Also, the freshest imagery of the closest star you'll find. We've got hundreds of cosmology segments. We've got Smashomash.org presents the sun. We've got product review videos and lots more. Thanks to everybody who supported the channel. If you want to really support our operations, consider becoming a member of the Smash Team at smashomash.com/SmashTeam. That is the official subscription services site of the Smash News Network, least busted name in news. You can also find links to our Hemp Lucid shop there. Don't forget to enter the promo code SMASHOMASH to save some dough on checkout for your Hemp Lucid order. You can use the promo code to save some dough, or you can shop via our link right there on the homepage at smashomash.com. Join at the gold, the silver, or the bronze level to receive email alerts about disasters. Again, we talked about how we didn't send out the NOAA alerts about KP7 because we saw the magnetic field dropping. So anyway, smashomash.com is the homepage. And welcome to the Neo Renaissance. Visit us on social media. We still are on Patreon as well. So help us out via clicks if you like. And don't forget that we will indeed be streaming for the equinox. So at the spring equinox, it'll be on March 20th around 5:24 p.m. and 5:24 and 20 seconds. I believe is when that happens. Yep, 5:24 and 20 seconds. As we count down to spring, only 5 days and change left for winter. Yes. So make sure that you put that on your calendar. We'll start streaming at about 5 p.m. on Monday, March 20th. It'll be a live YouTube exclusive, our equinox stream. And what we're looking at here is sea surface temperature and surface winds. So we'll go around the Earth here and check and see what's going on in terms of sea surface temperature anomalies. So check it out. The west coast of the U.S. is cold. The Gulf of Mexico is hot, and so is the eastern seaboard here. I mean, except right around the coast, up to about North Carolina, you've got very cold water, but just offshore, you've got very, very warm water. Look at how warm this is. 20 degrees Fahrenheit above normal. So, yeah, I mean, if you're worried about the planet turning into a snowball, it's just not happening. Also, we see this cold water in the equatorial Pacific continuing to break up. La Nina is over, folks. That is, put a fork in it. It is done. Also, hot water around southern South America. It is summer down there, after all. It's also summer for Antarctica. And summer's ending. Most of the water there around the Southern Ocean is anomalously cold. New Zealand is in hot water. Is it because of their government? Or is it because, no, they're just literally in hot water? Anyway, very cold water here around Indonesia. Hot water around Japan. Anomalously cold water around the eastern side of Greenland. Anyway, let's move into our regularly scheduled meteorology. So this is the surface wind scenario for the east. Surface wind scenario. There is the jet stream scenario for the east. Jet stream scenario for the west. There you go. Surface winds. And you can see that low pressure there loitering off the coast of Cape Cod, exactly as we forecasted. There is the surface wind scenario for the central world. That's Africa, Europe, and the Middle East. And here are the jet streams. And before we move on, quick note about snow. We've seen a seventh winter, a seventh consecutive winter of record snow for the Northern Hemisphere. Yeah, that's 7 winters in a row, folks. And so let's start with the snow mass balance. The snow mass balance, you can see here, well above the 1982 to 2012 average. Well above. And by the way, they need to update that and create a new plus or minus 1 standard deviation graph there, which includes 1982 to 2022 instead. You can see well above 1 standard deviation there, which is the blue standard, the blue shaded region there. Very high snow mass balance. Keep in mind this does not even include mountains. So very, very high snow mass balance there. As far as the snow extent, it's actually on the low side. It's almost less than 1 standard deviation below normal. So below normal in terms of the extent, that's only the 2-dimensional snow. It doesn't really tell you too much about how much actual snow, as a dusting shows up the same as a foot. Last but not least, look at the snow water equivalent. It's practically off of the graph. So they're going to have to expand this graph here, snow water equivalent, and let me just state, it's going to be an epic melt season. So if you've got to do things to prepare for massive amount of meltwater coming down from the mountains, for example, please do so. Be prepared for it because, again, look at the epic snow water equivalent. That's actually the highest of the past 7 winters, I think. I mean, I don't remember seeing it ever that high. That's like, I don't know how many standard deviations above normal it is, but just look at the graph. That is a lot of snow water equivalent for the Northern Hemisphere. That's the entire Northern Hemisphere. So anyway, quite a bit of snow on the ground. If the temperatures suddenly rise in spring, it could be a little bit disastrous. And we have seen some disasters as a result of snow melt in the past, doing things like delaying planting, destroying seed crops, and so on. So anyway, here's the current situation for clouds and fog over the Americas. And here's our weather.gov map. So as we zoom in closer and closer to the lower 48, here is your weather.gov weather warnings. You can see some freeze warnings there for the southeastern U.S. If your location's lit on the map, just click your location. Those are too many counties for us to cover in this brief meteorological experience. Let's continue on to look at some forecasts. So here is our temperature anomaly forecast in degrees Celsius based on the GFS model for the next 72 hours. And St. Patrick's Day is forecast for being nearly about, now pushing 60 degrees for Lehigh Valley, Pennsylvania. Should be a delight. You can see some very cold air in the north central U.S. especially. We'll also show the 72-hour GFS pressure and precipitation forecast. It shows you pressure. It shows you precipitation, both rain and snow. And we'll also show the total accumulated precipitation in inches. Since there's quite a bit of precipitation there, it'll be a mix of rain and snow, so heaviest rains there coming to places like Louisiana, Mississippi, Alabama, looks like. Again, that's your 72-hour GFS total accumulated precipitation in inches. We've also got your windy.com snow forecast. This is new snow over the next 3 days. Additional snow there coming to places like Colorado, Wisconsin, etc. That's the GFS model. Here's the Euro model. Euro model for new snow over the next 3 days. GFS model for snow over the next 3 days. Euro model, GFS model. And let's move on here. We don't want the video to be too lengthy. And there were some very strong lightning storms over the Yucatan Peninsula. So major lightning there over the Yucatan. Also southeastern Mexico there. And some serious lightning over the Caribbean. Continuing on to our lightning maps from lightningmaps.org. Give it a minute to connect. We want to see the current lightning strikes. That's a real-time lightning map. And we show that briefly just to show folks where the current strong storms are located. Middle East there, getting some thunder and lightning this afternoon. Continuing on to our vertical motion of the air column. Those ground-based systems known as Doppler radar. And we'll focus on the lower 48 to close the video out. There is U.S. Doppler radar. Phoenix, there's some rain moving in. And here is the clouds and fog. That's 3.9 nanometer infrared radiation from the NASA GOES Interactive Weather Satellite Suite. As you can see, that low just hanging out. It's loitering off the coast of Cape Cod. Yeah, Cape Cod. And as we stated yesterday, you can see it's now been completely encircled by dry air, so it should fizzle out as there will be limited convection available with all that dry, massive air tamping things down. Here's your recap. U.S. Doppler radar. Infrared radiation, showing clouds and fog when it's dark over half the country. And there's the water vapor map. Hopefully, if you understand atmospheric physics, it'll help. It looks like a clear day over the northern Gulf of Mexico. And thanks for tuning into the Smash News Network, least busted name in news. We're still amazed that you were able to find the channel in the first place. In the meantime, I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Please don't forget to visit the links here and here and here.